Users love screens that feel fluid and show continuity between transitions. In a previous video, we covered how to get started with the basics of shared elements in Jetpack Compose. In this tip, we will cover a more advanced example application of shared elements and how you can also add moments of delight to your app. In Androidify, we are using the new material shapes that come as part of the Material 3 Expressive update. We have two screens, the creation screen that shows the camera button and the camera screen that shows the camera viewfinder and the related buttons. Currently, we transition between the two screens, but we don't have a nice animation between the two. So, what if we wanted to transform between the Take Photo button, which is this delicious cookie shape, to the full screen square that the camera screen takes on as a shared element? Slowly having the cookie reveal the camera screen as it grows in size and transforms to the screen's rectangle shape. We need to do three things to achieve this animation. Use shared elements to grow from the photo button to the camera screen, reveal the camera screen as the button grows in size, and clip the shared element to the morphing shape. So, for step 1, we use the same concepts shown in the shared element video that's linked below. Firstly, we need to make sure that the top level of our app we are using a shared transition layout. We've placed our shared transition layout at our top level of the theme in order to use it all throughout the Androidify app. We also set a composition local for the shared transition scope, so that we don't need to pass the scope around. The next step is to ensure that we have an animated visibility scope, which drives the transition between the two screens. We are using Navigation 3 in this sample, which provides a built-in composition local we can access when needed. Perfect. Now, we have the correct scope set up. We can add the shared bounds modifier onto our content. We first add it onto the Take Photo button, passing in the key and the animated visibility scope from Nav3. We then add the same modifier onto the full screen camera screen composable. We should have a shared element at this point. However, we'd like this effect to be a little bit more sophisticated. The camera contents to grow from the size of the originating button to the size of the screen. It's not the effect that we are going for. We'd prefer it to stay in its final end state and be slowly revealed to the user instead. We call this pattern the reveal pattern. The other issue is that the shape isn't morphing between the two just yet. So, for step 2, let's create a wrapper to hide away the implementation details and make the usage neater. We will call this function shared bounds reveal with shape morph. We provide in default scopes from the composition locals, the shared transition scope from the shared transition layout, and the local nav animated content scope from Nav3, and switch our usages to use this modifier that wraps shared bounds instead. The other values are the same defaults that the original shared bounds modifier uses, but we need to expose them to be able to use them in our usages too. To tackle the issue of the camera not revealing, we need to tell the underlying layout that it should stay in place and skip the look-ahead measurements and placement. To do this, we add the skip to look-ahead size and skip to look-ahead position modifiers. These two modifiers will ensure that the content placed after the modifiers will not be animated or moved when the shared element animation is happening. Running this, we can see that the animation looks like a reveal animation instead of growing to the camera viewfinder. Right, for the grand finale, the actual shape morphing. This can be achieved using the new material shapes. The great thing about these preset shapes is that they are backed by the Android X graphics shape library, which has built-in morphing capabilities. This means that we can provide two shapes, create a morph between the two, and pass in the progress value and have the shapes transform between the two. To incorporate the shape transformation, we need the two shapes passed in, the resting shape and the target shape. Each instance of shared bounds needs both, as the transition shows both elements at the same time on screen as it transitions. So we need to ensure that we are matching up the incoming and outgoing content with the exact same shape as they transform. So we update our modifier to take in a resting shape and target shape as parameters. We then need to also create the morph object. We provide the resting shape and the target shape as input into the morph. We also need to create a progress value that animates between 0 and 1 to be able to perform the morphing. To do this, we tie into the animated visibility scope transition object and use animate float to animate based on the enter and exit state of the transition. For example, when the shared element is fully visible, we'd like the resting shape to be the shape we use. so the visible state has the progress set to 0. Okay, we now have the shapes passed in, the morph object set up, and our progress between the two shapes in place. Now we need to figure out how to get the changing path that'll be used as the clip for the animation. To do this, we need to create an overlay clip. We will call ours Morph Overlay Clip, where we pass in the morph and the animated progress value. We will get to the implementation of this in just a second. This clip is provided to the shared bounds modifier as the clip in overlay during transition variable. This shape clip will apply during the transition between the two states when the animation is active. The morph overlay clip implementation takes in the morph object and the animated progress. We override the getClipPath function. This is what the shared bounds modifier will call as it's transitioning between the two elements. First, we need to scale up the morph object to the size of the area that the animation is performed in. In this example, we use a matrix to perform the scaling operations. We get the max between the width and the height to scale it uniformly, not to stretch the object. We then call toPath on the morph object with the animated progress to get us the morphed path at that particular point in the animation. To scale the path up to the size of the area, we call transform with the matrix that we created previously, and we translate its offset to the center of the drawing area. We then return that path to be used with the shared elements. Now we just need to make sure that both our call sites pass in the correct shapes into the content. On the camera screen, the resting shape will be the rectangle, and the target shape will be the cookie 9-sided shape. The cookie button will have the same, but in reverse. The resting shape is the cookie 9-sided, and the target shape is the rectangle. And that gives us this ultra-fabulous, expressive, delightful shared element transition between the two screens. Oh, and did I mention it's also compatible with predictive back? You can see as we slowly pull back, it animates between the two screens. And that's it for this tip. To check out the full code sample, head to the GitHub repository. Bye for now.